the moderator for today's workshops. For our topic for today is multi-tenancy and network policies, and Marek will talk about today's agenda in more detail. Next, Edward will focus on the stream access management or SAM platforms that we designed and developed. And after that, Marek will provide a focused look at how multi-tenancy and network security are handled in Excalibur SAM, our platform for secure streamed access management. Next, you will see a live demonstration of tenant provision and configuration, so we can understand how new tenants are securely set up and customized. After that, we will discuss how network policies work within Excalibur SAM, highlighting our two-layer security model. This will be followed by another demonstration showing how network policies are configured and managed for individual tenants. We invited you to participate actively in the workshop by asking questions and contribution to the discussion at any time. Of course, there will be also a dedicated Q&A session at the end, but if you would prefer to postpone your question, please post in the chat under Q&A and we will get back to it with an answer. If you would like to ask questions during the session, simply raise your hand and we will give you an opportunity to ask or discuss directly. Marek, the floor is yours.
Thank you, Natalia. So, welcome again, and let's start with the session. So, I think, Edo, you could introduce the Excalibur as a company with a short overview and then give us some information regarding the Excalibur SAM principles. So please go ahead.
All right, ready for doing so. Okay, perfect. So every workshop we are doing is a kind of recapitulation. So Excalibur is a kind of a Slovakian-based cybersecurity company, so fully developed and fully designed over here. Yeah, we are specializing on the MFM and PAM solutions, and we are members of the multiple bodies of the cybersecurity within the European Union, and also fully certified for the ISO audits. Besides, we are also part of the defense fund, European Defense Fund, which is kind of a extended hand of the European Commission towards the defense of the whole European Union. So these are kind of the basics. And if you, Marek, please slide to the next one. Yeah, the basic comparison about the standard privilege access management tool and the SAM, the stream access management. Basically, the privilege access managements are focused on the privileged few, so some administrators or some IT managers or some like important people within the infrastructure, and they are protecting basically those. What is the current setting is that also standard users can be attacked, the credentials can be stolen, and the attackers can get to your infrastructure also through the basic users. So that's why we are widening the protection umbrella also under over also these basic standard users. And we are doing it through the stream and isolation of the users. Basically, we are streaming the connection towards the user instead of extending it from the infrastructure directly to their computers. So these are the basic information. And there are a few layers around this. One of these layers is the multi-factor authentication, which acts as a gateway to identify the user before he can enter the second layer, which is the dashboard. And the dashboard basically acts as a coordinator, which part of the system the user can access, what he can do there. If there is any connection, you need to be able to see how it's done. And once the user is doing anything that he needs to in his like duty, we need to be fully auditable and we have full like visibility and transparency of the actions. So everything is fully logged as a comprehensive log, and also as a video if it's connecting to some direct targets from the infrastructure. All of these is protected by the biometry, which is used in the first step. So the biometry used as authenticator is used also for the dashboard and also for the auditability and visibility. So any action is connected directly to the Face ID or the fingerprint. Then, of course, there is a fourth layer, which is the AI oversight. And this AI oversight is basically acting as a cybersecurity specialist on top of each shoulders, meaning there is a contextual analysis of what is happening during the session. And if there is anything that shouldn't be within the context, the AI will be able to stop it and send all this information to the administrator for the review. So this is really from the high overview of the product, of the philosophy around it, and I guess we are ready to go to the focus topic with Marek. Thank you very much.
Yep, thank you, Edo, for our introduction and short summary. So let's begin with the main topic, which is basically focused on multi-tenancy, its principles, and how we managed to build in the multi-tenancy functionality into the Excalibur SAM. All right, so first we can ask what exactly is the multi-tenancy. So basically, it is the foundational concept in modern software architecture, especially the applications that they are delivered or provided as a service. It basically means that the single application and its infrastructure is used to serve multiple customers or tenants at the same time. So each tenant could be, and the best scenario is that each tenant must be completely separated as the organization or department or maybe a business unit within the same organization. And all the data, configuration, and user accounts are completely isolated, not visible to each other, and private. The reason why the multi-tenancy is such a popular, it allows is basically because it allows multiple clients to share the same underlying platform, infrastructure, application instance to help companies reduce their costs, centralize the management of all the application infrastructure, and with possibility to scale up to many other customers or companies without duplicating the resources. So in practice, I can deploy such multi-tenant system on basically a dedicated cluster or some existing cluster. And since there is built-in multi-tenancy, I do not need to take care when I'm trying to provision a new tenant to prepare such infrastructure or dedicated cluster again. And also for the tenants, the user experience is seamless and basically the same. So each user from each tenant interact with the application in the same way, but that user interface is dedicated just to the organization into which the user interacting with the application belongs to. So behind the scenes, the architecture must ensure the privacy, separation of all the application components, and also the data isolation as well. Regarding the multi-tenancy types. I prepared a small picture which basically describes types of multi-tenancy. So there are 4 or 5 together. So first one is where we have a separate application, and each application uses its own separate database. Then we have shared application components between tenants, and each tenant uses his own dedicated application database. The third type is when we share application components and application database as well for all the tenants. And there is maybe some other models. One of them is a hybrid model where, for example, we share some application components. The rest is dedicated for the tenants, and the same is with the application database. So maybe there are some shared data between tenants and some dedicated data in appropriate databases regarding the tenant isolation. So what are the benefits? Yeah, I already mentioned some of them, but the first one is the resource optimization. So to have multiple tenants, and if they share the infrastructure and services, organizations can reduce hardware and operational costs. Also, and to make this kind of utilization, and also the expenses more to be more cost effective. Second, the maintenance becomes much easier because in the multi-tenant application, we are talking just about the simple and one type or one kind of infrastructure, and also we are talking about the single application instance. So all these components can be then managed centrally, and this means that all tenants benefit with, for example, when I upgrade the application, or if I bring a new functionality into the new version, then all tenants benefits of those new functionalities at once. So it greatly reduces the downtime and also the management effort to manage such kind of infrastructure. Okay, the third benefit I think is a good one and related to scalability, because typically organizations usually grows. So they need to onboard their new customers or clients continuously. So the system must be able to quickly adapt to these changes without any massive investments into the new infrastructure. So then we are talking about the ability to scale up, for example. And also, if there is a need to save such resources, when we are talking about the need to scale down or to provide less than usual for the clients. So there must be also an ability to scale down to save investments. Yeah, I was talking about the user experience. So basically, the multi-tenancy of the application provides possibility of consistent experience, not only for users from single tenant, but also for the other users from other tenants. So all the tenants can access the same functionality, and all users from all tenants can experience the same environment, the same functionality, and so on. Yeah, simplified operations I was talking about the management, about the need to take care about the environment, but also we need to talk about possibility to monitor the infrastructure, and also a possibility to provide easier troubleshooting and technical support. Okay, so I was talking about the benefits, so now let's talk about the challenges. The first major challenge is related to data or tenant isolation themselves. So we need to ensure that one tenant cannot access data of different tenant. So different data, the data of different tenant must be then isolated, and this requires to build up or to design a secure boundaries at almost every layer of the application. Database, APIs, also the user interface, front end, back end, and so on. Yeah, when we are talking about the data isolation, we are also talking about the security concerns as well.
I'm sorry. We would like to ask to mute your microphones.
Yes, thank you. It is better now.
Thank you.
Okay, so yeah, when we are talking about the data isolation, so we must be sure that there are no possibility to leak the data between the tenants. Also, we must be sure that there is no possibility or backdoor to breach from one tenant to the other one. Or we must be sure that there is no possibility to somehow misuse the multi-tenant functionality, maybe by the system administrator or the tenant administrator, and so on. The other challenge is, for example, that we have multiple tenants, and one of them is quite performant, so it is taking quite a huge load of the system. So we must be sure that this does not affect in some negative way the other tenants. So we are trying to avoid such situations, so the noisy neighbor is not able to affect the other tenants in any possible way. So we need to take care about the usage spikes, and also about the scaling itself. So also we need to somehow think about the possibility about the customizations. So many tenants have different uh, needs or specifications or processes, how to use the application, how to configure it. So there must be different layer of flexibility than in the legacy or standard non-multi-tenant applications. So there must be such functionality possible. And also the main challenge is the compliance as well. So we need to or we must be ensure that the regulations such as, for example, GDPR or NIS2 or ISO standards are applied, but not only to the platform itself, but for every tenant as well. So to, for example, overcome these obstacles, multi-tenant systems need to be carefully designed, throughout tested and also proactively monitored. So yeah, these were the most challenging facts about the multi-tenant applications. Okay, so let's talk a little bit about the Excalibur, how it handles those specifications and requirements to be multi-tenant platform or application. And yeah, first feature is the dedicated user interface. So basically, Excalibur SAM ensures that each tenant operates within his own dedicated user interface. So the data flow of users or other workflows are completely isolated from each other's. In the past, in a different workshop, I was talking about the possibility or a design feature that the PAM sessions are flowing through dedicated application components, and this is the second feature that Excalibur SAM provides to achieve multi-tenancy in the right way. Um, so some of the application components are dedicated to each tenant, and these ensures that it's not only isolated on the tenant level, but it is also flexible and allows us to scale up or scale down without any effort. And that's the third requirement to have a scalable design. So Excalibur as architecture is designed for a scalability right from the beginning. So as for example, your enterprise will grow and new tenants will be onboarded in the future, you can do that quite quickly, effortlessly, and efficiently without impacting the performance or availability of the already existing tenants. And also, this is possible without compromising any security. So yeah, these three cornerstones makes Excalibur flexible, secure, and also future-ready solution for managing stream access management in complex organizations. Okay. Yeah, a lot of those details on this slide was already explained, but yeah, let's go a little bit to the details. So dedicated set of application components. Yeah, this is possible because Excalibur runs on the Kubernetes cluster. So Kubernetes as the modern platform or cloud native platform or environment to run such applications allows us to provision each tenant with his own set of configuration objects, application components, and other very important details regarding each tenant provisioning. Okay, each tenant can have his own set of identity stores configured. It doesn't matter if it is the local identity store or Active Directory based one or Azure Entra ID kind of identity store. In previous workshops, I was talking about these in much details, but basically each tenant have or can have his own dedicated set of configured identity stores, and there is basically unlimited number of them And also some of them, for example, the Active Directory type of identity store allows you to configure more domain controllers to connect to. So you can have multiple configurations of each type of identity store. And regarding the Active Directory, you can have multiple connections configured as well. Now let's talk a little bit about the security and security-related configuration objects. So those are dedicated to each tenant because the system security configuration is basically done or achieved in the same way as the tenant security configuration, because the system environment is basically the tenant as well. We call that system tenant or tenant zero. So some of those configuration objects related to security can be managed only by the system administrator, and the rest can be configured by the tenant administrator himself. Some of the security configuration objects can be shared between the system tenant and the regular tenant, but not between tenants themselves. Why? Yeah, basically due to tenant administrator is not a technically based person. He doesn't understand all the configuration details or the mechanisms how Excalibur SAM works. So system administrator can prepare such configuration objects for tenant administrator, and tenant administrator then can use these objects in his configurations. Security objects created in the system tenant can be used by tenants themselves, but they cannot be modified by tenant administrators, only by a system administrator. And those security objects are security policies and rule sets, also the geofences and geofences groups, and network policies. Regarding network policies, I will talk about them a little bit later, but now let's focus on to the security policies and rule sets. Those can be configured by the system administrator and provide these objects to the for the tenants. But tenant administrator is also possible to create his own set of security policies and also rule sets. So he does not need to use those specified by system administrator. So there are two layers of possibilities to configure security policies and rule sets. Network policies is a little bit different setting, but I will talk about them later. And also there will be demo related to network policies, so we can deep dive into them later. Okay, I was talking about the dedicated application components provisioning. So those components are the session management. So you can imagine them like the PAM session orchestrating engine. So it is taking care about the incoming requests of users to provide such PAM session. So PAM orchestrator will connect to the session management and ask, okay, this is the request from the user. Please create such session, and then if ready, please give me the information about the session so I can route that directly to the appropriate user from appropriate tenant. So that's the session management. Also, there is the session recording engine dedicated to each tenant, just to be sure that the encoder is working with the session stream of that particular user from that specified tenant. So there is no room, there is no space to somehow mix those data between tenants, since the session recording engine is dedicated per tenant. Also, when we are talking about the PAM sessions, we need to talk about the web-based PAM sessions. So the virtual browser is also a dedicated component for each tenant. So each tenant has his own running virtual browser instance. Then, when we need to automatically scale the possibility to provide more users with PAM sessions, we need to be talking about the session load balancer. So if there is some kind of peak of requests to start new PAM sessions, then we usually spawn a new session recording engine, and then we need to somehow load balance the requests between existing one and new one. So there is also the dedicated session load balancer. And also, since those components are components of Kubernetes type deployment, each deployment must be covered by related Kubernetes service. So yeah, every related or relevant Kubernetes service is also dedicated to a provisioned tenant. Okay, Kubernetes cluster configuration objects are also dedicated when the new tenant is being created, and those are network policies and horizontal pod autoscalers. Network policies, I will talk about them later because we need to differentiate between two levels of network policies. The one level of network policy is the Kubernetes based. So basically we are configuring the Kubernetes egress, not ingress, but egress output controller to configure it with network configuration details, which is managed by the system administrator. And that's the first level. Then there is the second level of network policies, which is application based. Yeah, later. Also, the tunnel client related components are dedicated as well. Simply, we can tell that the tunnel server listeners are completely isolated and independent from each other, and basically it does not matter if it is tenant related or not, but since there is the dedicated tunnel server listener for each tunnel client configured and connected, so we can safely say that the tunnel client related components are tenant based or tenant dedicated as well. On the picture on the right side, I have taken a screenshot from the dashboard, so we can see all those related components. Some of them are the application load, basically running pods, and the rest of them are configuration objects. Configuration objects such as, for example, I turn on my laser pointer, Yeah, network policy is basically the configuration object. Pump tenant deployment, yeah, that's the running application workload. Envoy is mentioned, session load balancer. GUACD, so basically Guacamole engine, is the session recording one. Virtual browser deployment is this this one, dedicated virtual browser. Virtual browser tenant autoscaler, yeah, it belongs to this second category. So horizontal pod autoscalers. Yeah, I see there is a question. Okay, I will finish this topic and we'll answer in a few minutes. Also, I was talking about the services. So relevant Kubernetes services, virtual browser service, PAM tenant service, Guacamole service, and there is another special one, a PAM tenant one, headless. It is just a configuration object. And then obviously a configuration map for the load balancer, and basically this is it completely. So all the tenant-based dedicated application components, including the workload and configuration objects as well. Okay, so let's return to the question. Why Excalibur SAM provisions only selected application components for each active tenant? The answer is simple, because we need to save required system resources. So typically CPU, RAM requirements, and also storage necessary to run those application components. But those components are designed in such way that it is almost impossible to somehow leak the data or breach the data or breach the boundaries of each tenant to some other one. Okay, is the answer clear? I think so. Okay. Any other questions? No. All right, so let's continue. And we will continue with the multi-tenancy demo. Okay, so I'm going to try to share my screen. Hopefully you can see all the windows. So when I was talking, and maybe it is also the answer for the question, why only selected application components? Yeah, because for example, regarding the user interface, there is a built-in functionality that user can make a bookmark of his own tenant, because each tenant has a dedicated URL of the user interface, basically of the dashboard. So the user can create a bookmark and can log in directly to his dedicated tenant user interface, because the mobile application is multi-tenant as well. So the tenant application basically allows users to be registered in multiple environments. Each environment can be multi-tenant, so user can be registered using multiple user accounts in multiple environments consisting of multiple tenants, and each environment can be configured in a different way. So yeah, you can mix those details completely together. So multi-user functionality together simultaneously with multi-tenant and also multi-environmental possibilities. So as you can see, those blue sections are the customers. And each customer also can have multiple deployments or application instances running. Each application instance can be configured in such way that it consists of multiple tenants. For example, let's check the Excalibur company. Currently, I have multiple user accounts registered in different deployments or application instances. So these or those marked with green dot are application instances. When I open, for example, the lab environment, I can see that there are multiple tenants marked with this blue frame. And under each tenant, I have different user accounts configured. And one user account I have registered in 2 tenants simultaneously. Okay, so hopefully you get the point, so you can understand what's going on. And yeah, let's try to log in to this user interface. It is asking me, okay, please provide a biometry. So I will. It is asking me to provide a PIN code, TO. Okay. And I'm in. If you carefully check the tenant name, I'm currently signed into the tenant, which is called demo tenant number 1. Because I used dedicated URL for this tenant. You can check, yeah? This is the dedicated URL. If I want to, for example, log in with different account into the different tenant or maybe to the system tenant, I can do so. Basically, I will remove this part of the URL, or there is a possibility to do that with a single mouse click. Here is the button with the house icon, but this means I'm going directly to the base or URL base, which is the login screen or user interface dedicated for the system. But it also can be used to log in to a different tenant. But then I need to select the proper user and proper tenant within my mobile application. So let's do so. Okay. Since my mobile application knows that I'm using multiple users, that information is listed directly on my phone screen. And also there is one important information that the James McNeil user is able to sign or to log in to different tenants. So let's check. Yeah. Now, then when I select the proper user, and that user is or can log into the different tenants, so the mobile application is asking me to select one of those. So I will do that. Okay, there is the peer verification required to log in. Let's confirm the peer verification. I will do that on my phone, but with the different user. And I will select that user for peer verification like such. So not only the login functionality is multi-tenant, but also the peer verification functionality is multi-tenant as well, because it must be. Okay, successfully not logged in, but user verification was successful. So let's now scan the QR code. Let's select the James and let's select the system tenant. Yeah. Now I was not in need to provide any kind of biometry, any kind of PIN code. Also, there is a valid peer verification record in the application database. So the only step was needed by this user was just to scan the QR code, and that's it. Okay, so since James McNeil is able to switch between multiple tenants, let's check. Yeah, it's correct. So James can operate within the system tenant or tenant which is called demo tenant number 1. Okay, I will log out with the account James. Okay, my URL is correct to sign into the system tenant. I will use different user to do so. Okay, I'm logged in to the Excalibur SAM dashboard with the Excalibur administrator permissions. And let's check the tenants. So tenants, tenant list. This is it. There are multiple of them already created, already configured. Since Excalibur actively communicates with the underlying Kubernetes cluster, it can periodically check if all necessary dedicated tenant application components are running, are ready, and so the status of that is completed. Let's create a new tenant. So I will click on the plus button. I will create a new tenant which will be named workshop tenant. I can also specify the alias, which can be then used in the URL. So please remember this alias workshop tenant. Later on, we can check how to work with this alias configuration detail. All right, so new tenant, network addresses, network policies. I will take care about them in the rest of the presentation and in the next demo. Okay, I'm ready to save the new tenant. Let's do so like such. Let's go to the end of the list of tenants. And as you can see, the Excalibur SAM application was talking to the Kubernetes API interface. Please create and run those and those dedicated application components for this tenant and tell me when ready. So there was the status of provisioning. Now it is completely completed. So we can see the green status that everything's ready and everything's fine. Okay, tenant is configured, but now what else to do? First, we need to configure some kind of identity store because we have the tenant already created, but nobody will be able to log in to that tenant because there is no identity store configured, there are no users invited nor registered. So let's create some kind of identity store which will be dedicated just to this tenant. Okay, again, plus button. We can select 3 different types of identity stores. For now, I will select the local one because I don't want to configure anything complicated. Just to work with the local users is currently enough for me. Okay, so workshop tenant identity store number 1. I will say the button. Okay. I will click on the symbol of the pen or icon of the pen, and I'm going to create a new users. So let's click on the button to add new user. So new workshop tenant user. No, I will do it like this. Workshop tenant 1, user 1, and the surname will be, or let's do it like this. Workshop tenant 1, user 1. Email, some kind of email needs to be configured. So for example, I don't know, maybe user 1 at company.org, like such. Now I can save the user, or I can directly send him the invitation if I need to. I will just save the user. I click on the pencil again. Sorry, not this one, but this one. No. I want to add new user because I want to show you something. Let's do it like this again. Workshop tenant, users. Okay, still no user. Okay, let's go back and let's click to modify. No, identity stores. Yeah, like this. And I want to add new user. Okay. There is possibility to import new users using the comma-separated text file. And there is also possibility to check the help, what kind of format is expected by Excalibur SAM to be able to import comma-separated values file from the with the list of users. This is it. Or you can directly download the template, fill her up, and then upload to the Excalibur SAM. Okay, so one user is created. Now we need to check the invitation of it. So let's go back. Let's check invitations. Okay, there is no such invitation for the user. Yeah, there is no, because I did not invite him. Okay, let's do that again. So invitations, I will click on plus button. I can see my previously created user, and I will click to invite him. Since it is the first user, I need to create, or it is a good practice to create the administrator role or configure the administrator role for that first user of the tenant. Okay, so I will click on invite. All right. Okay, so invitation has been created, and I will use that invitation to register. Let's do so. Okay, so copy the invitation link. I will open the incognito window. All right. This is the invitation link, and I need to provide the verification code. So let's check. This is it. Copy paste, verify the code. All right, configured. Now I will scan the registration QR code. I will register as the user, and that's it. I was successfully able to register to the new tenant with his own dedicated user. And as you can see, now I'm administrator of the tenant, but I need to switch to the administrator role manually, like such. All right. And now I can completely manage the tenant as needed. So I can manage the users. I can work with the invitations, so I can invite new users to the system. I can, for example, check the or to work with just-in-time access functionality in the PAM engine if needed. I can then create new PAM targets as I need. I can create new tunnels. I can use built-in Excalibur MFA as integration into the third-party applications. And also I can check the audit logs that are dedicated to my tenant now. I can also create and manage my own geofences and geofence group. Most important information regarding the geofences, as you can see already, there are some configured. You may be asking why. That's because those objects were already created within the system or within the system tenant, so they are available for tenants as well, but tenant administrator are not able to modify them, just to use them. And the same is regarding the geofence groups and also regarding the security policies and respective rule sets. Other possibilities, such as identity store configuration, again, each tenant can have his own dedicated set of identity stores configured. And if necessary, the tenant administrator can provide his own Google Map API key to be able, for example, to configure geofences and geofence groups. So he can use Google Places functionality, location name resolution, and also he can use the country borders as the geofences configuration. Why, you may ask, why this is not available out of the box? Because those functions or functionality provided by Google is a paid feature. So it is paid or pay model is as you go. That means how many requests you will generate, as much you need to pay. So that's the reason why the tenant administrator must provide his own Google API key. Okay, that was it regarding the tenant configuration. And now let's check that URL. So in this window, we can check the URL alias or the tenant alias, which is called workshop hyphen or minus tenant. Let's check that when I logged out from that new tenant. And here, as you can see, this part of the URL is that tenant alias specified in tenant configuration. So basically, if I would like to, for example, go directly to the demo tenant number one, let's check the alias of that. This is it. So now I will replace this workshop tenant value with demo tenant one value, like such. We'll hit enter. And as you can see, the login details has been already changed from workshop tenant to demo tenant number one. That's it. Okay, so let's continue with the presentation. I almost forgot. Any questions regarding this? Nothing so far. Okay. Let's continue. Okay, Excalibur network policies. I promised I will talk about them later, so here we are. And Yeah, so let's talk about them, why they are so important, and how Excalibur SAM leverages the Kubernetes functionality to provide such possibilities to work with network policies. Okay, why they are important? Kubernetes network is typically a flat network model. That means all pods can communicate with each other within the same namespace using short names. And also, each pod is able to communicate with other pods in different namespaces as well. They need to use FQDN, but it does not matter since the communication is allowed to be performed. So we need to somehow, yeah, and the most important detail is that when the pod wants to communicate to the outside world, the internal IP address of the pod is then translated to the IP address of the node on which that pod is running. So we are not able to utilize functionalities on next generation firewalls because basically we lost the information about the source, about the identity of the source. Since we do not know the origin or original IP address, we do not know the name of the application. Also, we do not know what kind of traffic we should expect, since the traffic could be SSH, RDP, web-based traffic, and so on and so forth. So basically, on the traditional or next-gen firewalls, we are not able to work with such kind of information since there is no such kind of information. So that's the reason why here in Excalibur we brought this network policies functionality into it. And that's the reason why there is possibility to configure network policies for each tenant independently. Okay, so on this screen or screenshot or picture in the right corner, we can see how the communication or network traffic is being performed within the outside world of the Kubernetes cluster from beginning. So when the traffic is incoming to the Kubernetes cluster, then it is processed inside it, and then if the pods needs to communicate with outside world as well, how it is performed. So yeah, here you can see the simple scheme of it. Okay, those multi-layer network policies are, network policies are multi-layered. You may ask why. That's because the first layer is the active communication between Excalibur SAM and Kubernetes API. So if the system administrator will create a network policies for each tenant, those are reflected and configured as appropriate on the Kubernetes cluster itself. But we need to take care about the possibility that there is the Kubernetes cluster administrator that may change those network policies or remove them completely. In that case, whatever is configured within the Excalibur SAM will do not take place, will do not apply when some user will try to, or sorry, the tenant administrator will try to configure PAM target in such network segment that he is not allowed to. Hopefully you understand or you get the point, but typically tenant administrator will configure segments, host names, subnets, or specified IP addresses into which the appropriate tenant can communicate. If somebody will delete those network policies on the cluster level, they will no apply anymore. There will be no effect of them. So that's the reason why there is the second level or second layer of such network policies. So they are being checked on application level. And also there is such a basic network firewall functionality built into the Excalibur SAM application directly. Okay, so yeah, those network policies basically enforces or enforce traffic rules at the Kubernetes cluster level. Also, it controls the possibility to communicate or to create communication flows between dedicated pods and external resources. And also the network policies are dedicated to each tenant independently to also provide a strong isolation between tenants. There are some organizations, maybe yes, there is a question. I will react a little bit later. There are some customers or organizations that they want to use multi-tenant or applications based on multi-tenancy. And for example, each division or business units of the organizations are allowed to access only specified parts of the network segments, or maybe some isolated networks as well. That's the reason why there is such functionality available in the mean of network policies in the Excalibur SAM. All right. I already mentioned that the Excalibur SAM management engine actively checks presence of those network policies on the Kubernetes level. So also, if there will be some Kubernetes administrator that will remove those Kubernetes configuration objects, our application will detect that and apply the network policies again accordingly. Okay, so let's check the question. Are network policies evaluated and applied on Kubernetes cluster level or on specific Excalibur SAM microservices as well? Yeah, not only on Kubernetes level, not only on microservices level, but also within the application logic level as well. So basically, if the system administrator will allow only specified network segments or IP addresses, and some other tenant administrator will be trying to create new PAM target from network level that is not allowed, the application logic will check and also will notify the tenant administrator, no, you are not allowed to configure such PAM target because it is not allowed within the network policy. Also, if there is a request from the user to perform or to create a PAM session for such target, it will be not possible to, because the session orchestrator or session management engine will block such a request to create a session. Okay, hopefully the question is clear. The answer is clear. Any other questions? Nothing so far. All right. Let's perform some demo regarding the network policies. Okay, I have created a tenant which is called workshop tenant. Let's go back and let's switch to that tenant again. Tenant lists right at the end, workshop tenant. Let's check the configuration. Okay, network. This is the place where the system administrator can configure such network policies for each tenant independently. Notice, when there is no such network policy configured, it means that the tenant communication is allowed to everywhere, to every system, not only the internal, but also the external, also the internet, or also some other maybe private network segments or subnets. Also, other notice, when the system administrator is creating such network policy, he needs to ensure that for example, DNS services are allowed. When the tenant administrator will create a PAM target based on host name, not the IP address, the PAM engine, when he will be trying to create a new PAM session, and PAM target is configured with the host name, PAM engine will ask the DNS service or server using the DNS query. Okay, dear DNS server, please provide me IP address for such host name. If there will be DNS traffic or DNS service or IP address of the DNS servers not configured within the network policy, such PAM sessions will be unsuccessful. So PAM engine will be not able to create such PAM sessions. Okay, I'm going to create a new network policy. So I can click on Add button, or I can import the configuration. Regarding import, you can use just pure text file. Those or values in the text file can be separated using spaces, using commas, or the IP address can be one per line or one per row within that text file. Also, I will show you that in the Add button. Also, possibility with the CIDR format is possible. So I can specify ranges. Also, such ranges are also allowed in this format, for example. Like such. I will save. Yeah, correct. Since my input was correct, there was no syntax error, everything's fine. I can add a new range, for example, like such. Maybe I will try this. Okay, it's saved, but what about now? All right, it did. but probably this is a bug because this should not be allowed to do so, since this is not a valid IP address. But I can try this one, for example. Okay. Maybe there is a bug, but maybe this version is buggy. But overall, there was such a check mechanism that was checking of correct format of the IP address to be provided. Also, I need to mention that the IPv6 format is available and can be used as well. Also, you can use a shortened IPv6 format when we are talking about the ranges, or if there are multiple zeros within the IPv6 based IP address. Okay, I will delete these stupid values because they are not correct, like such. Okay, so tenant administrator configured something for the tenant, and I'm going to log in to the tenant itself, like such. All right. Since I'm the no, sorry, I'm not in the right tenant. I want to go to the workshop tenant. Yeah, this one. Like such, okay. And since I'm the tenant administrator, I can create some kind of PAM target. Let's do so. For example, the RDP target, I will call it some tenant target, and I will use hostname, for example. Hostname like such. It is the Windows, so port is fine. I can create, for example, configuration of the login. Like such. I will enable file transfer clipboard as well. Session recording is turned on by default. All right. What will happen? Okay, I got a notification because the Excalibur SAM is telling me, no, dear administrator, this is not correct because this is not allowed by the system administrator. Your hostname is out of range. Okay, I will cancel. So I will configure in the network policy the host name because it is possible as well. RDP, like such. Okay, what about now? No problems at all. Nicely done. Okay, let's try to open the PAM target. And it works. All right. I will log off from the PAM target. I will additionally disable or delete that dedicated network policy. Like such. Okay, what about now? No. PAM target hostname is not in the accepted IP range. So this was the multi-layer network policy security built in the Excalibur in practical demo. So basically, this is it. This is how it works. And this is how it protects tenant administrators to configure whatever they want, whatever they like and maybe stuff that is not allowed to use or to configure, and that's it. So those network policies are controllable and manageable only by the system administrator himself. All right, any questions? There is one. Does network policy apply to no clients as well? Sure, it does. Because the tunnel client is providing me a possibility to connect to isolated network segments. That possibility to connect is a little bit out of range of Kubernetes-based possibility to provide network security. So that's the reason, or one of the reasons why there is the another level of possibility to protect those environments, and it is built into Excalibur SAM. Okay, yeah, it was okay. Any other question? Okay, nothing so far. So that was all from my side. Since there are any questions, I think
Yes,
it's all
I would
for
like to.
today. I will stop the recording in a while. Regarding these workshop series number one, it is all what we wanted to present to you, to bring you some interesting content, maybe some stuff, configuration details, information that is not available anywhere in the documentation, in the administrating or administrator or user guides, and this is it. But please keep in touch. Maybe in the future there will be workshop series number two. Also, we would like to bring you more interesting content. Maybe something that will help you in your daily working routines. So thank you again.
Yes, thank you so much, Marek, for your presentations, for all explanations, and thank you all for your time that you enjoyed us. And yes, we will let you know for if we'll have the future workshops. And if you have some questions, please write us. And right after the workshop, we will send you a short feedback form. So we will appreciate also to hear your feedback. So thank you so much and have a good day.
Thank you. Thank you all. Have a nice day. Bye bye.
Thank
Bye
you
bye.
all.
Thank you very
Bye.
much.